Welcome to the welcome to the statistic learning session. Today we'll be talking about a chi-square test, and it is for testing two modalities. In this, we'll do for when k is equal to 2. Before we begin that, remember that when we did one-dimensional test parameter test, we did for a Gaussian. It was absolute value and which became a square, and we have a critical value that becomes square of a critical value. And we are going to do something similar here where k is going to be 2. Now let's start with setting up the problem, and the problem is that we'll assign here k equal to 2. We'll assign here k equal to 2. Now let's start again. Working on this problem here. Now where we have is where k is equal to 2. So we'll say just to say that k is equal to 2 here, and this simplifies a multinomial distribution and to a binomial distribution, which is essentially a Bernoulli distribution. Now we are testing. What we are testing is that we are testing for this one is that whether p is to a p naught. That's what we are testing. Where the parameter p is equal to p naught. That's a null value, and alternate is that p is not equal to p naught. Now for this we need test statistics. Can you tell me what would test statistic would look like for a chi-square test when k is equal to 2? Just think about it. For test statistics, that would look like something like this, where n is equal to p hat minus p naught and p naught square plus n, and it's going to be some like 1 minus p minus 1 minus p naught and square 1 minus p naught. Now we have to simplify the second term. Can you think about how we can simplify a second term to more simpler form? This is how it looks like when we simplify a second term. The second term is 1 minus p minus 1 minus p naught, and it's 1 minus p naught, which is equal to p hat minus p naught and 1 minus p naught. Now the test statistics becomes Tn equal to n p hat p naught square 1 p naught 1 minus p naught. Now we need to combine these terms such that we are going to combine these two terms such that it is more simpler. So we need to 1 minus p naught plus 1 minus p naught becomes 1 minus p naught and p naught 1 minus p naught, which is equal to 1 over P naught by minus P naught. So once we do that, then the test statistic becomes N P hat P naught square and 1 divided by 1 minus P naught. Now finally, we need to put this in a square form, and this becomes this. So it's going to be 1 square naught and absolute value of P hat minus P naught, absolute value square and square of this, that is 1 square P naught 1 minus P naught square. So this is what we get as a final form. This shows that chi-square test for when k is equal to 2 is similar to a binary distribution to a test when single parameter is equal to p. Now, in the end, let me conclude by saying that chi-square test for k is equal to 2 is essentially the same as a test for a binomial parameter p. This is useful because it means we don't need to perform a separate test for a Bernoulli distribution. We can use the same test statistics. Anyway, let me quickly summarize what we learned today. We learned about a chi-square test for two modalities, and where we assign k is equal to 2, and we created some binomial distribution, and finally created a new test distribution for chi-square test, which is similar to a binomial distribution when p is equal to 1. So that's all for today. I will see you next week. Thank you so much. Have a nice day.